Okay, in this experiment we are going to demonstrate an endothermic process, and for this purpose we are going to use citric acid. Let's make sure you get the label right. Citric acid and sodium bicarbonate, and we are going to get in a reaction in which the process is endothermic. So we are going to measure the temperature prior to the reaction and then after the reaction, and we will see hopefully that the temperature does decrease. So first of all, we have our beaker here, and we have distilled water over here, and what we're going to do is basically get the beaker filled up to about, it's not very important. Here we have about 60 milliliters distilled water, and we'll place the beaker over here. Then we're going to take a scoop of the citric acid, and we'll use this nice guy right here to get a nice scoop. Okay, so let's be careful here. So here I'm showing the scoop, okay, and I'm going to pour that into the beaker. Let me add a little bit more citric acid. Now we have to dissolve it, so we'll get one of our nice stirring rods. And before that, let me go ahead and clean this spacklet, so, with distilled water, clean it up a little bit. It's good to have a few of these around. Actually, I do have one around. But you need to just throw it into the bin to be washed. So you really want to have two clean ones. Because the next thing we're going to do is scoop up some sodium bicarbonate, okay? But before we do that, the key thing we want to do is, let's get rid of this because we're not using a test tube. Okay, we have our beaker. We're going to get a stir. Okay, let's find our stir here. It seems to have dropped to the bottom of the pile. So here we have our stir. Let's go ahead and stir this real good. We want to make sure that the citric acid is completely dissolved in the distilled water. Okay, we're showing all the steps of the experiment. Don't want to skip anything. All right. There we go. I think we've managed to do that. Now I'm going to keep the stirrer there, and I have some litmus paper. Okay. So here's some pH test paper right now, and I'm going to put this in this watch glass, and I'm going to take the stirrer and get a drop of this dissolved citric acid onto the pH test paper, okay? And what you see is, it turned more reddish, so that indicates, of course, that this is an acid. This is a good sanity check. It's always cool to see this anyway, so I'll try to do that any opportunity I get. All right, so in fact, let's go ahead and see if we can do something here. We got our pH test paper. What I'm going to do, it has a nice color code. See if I can get this color code in front of the camera so you can get to see the degree through which we're talking about here. So let me hold this here for a while. Hopefully you can see this. Okay. And we see that we're pretty acidic. Got a good concentration going there. So, okay, so, and by the way, your test paper, make sure you put it back in the bag because you don't want it to get wet or anything. So put it in a plastic bag. Okay, so here we are. Now the next thing we're going to do is we're going to lower the thermometer into the beaker and register the temperature. Okay, so what I'm going to do is take the camera out. Okay, and let's go ahead and take a close-up view of the temperature. We're going to need this information to see how much the temperature changes. Okay, so basically, that's kind of funny to do, but here we go. You see this, we're around 20 degrees. You can see the mercury, so roughly around 20 degrees. Now, it's very important to know exactly what we are, and it's pretty close to 20. I also have a thermometer, a digital one. It's reading like 21.6, so, but the thermometer is better. So that's the actual liquid which we're interested in. So, so we're reading about right around 20 degrees. Okay, that's very important reading. So let me go ahead and put the camera back in. Okay, you're going to see a pretty good reaction when we add the sodium bicarbonate. We might actually get some overflow. So usually we want to collect that, but right now we're not dealing with the most dangerous chemicals. So what I've got is a scoop of sodium bicarbonate. You can see that. And now we're going to get a heck of a reaction. Remember, we're sitting at 20 degrees Celsius. Let's go ahead and dump a little bit more. Usually I'd be very careful, but this is sodium bicarbonate, which is baking powder. Okay, so we did get our reaction. Now it's very important to read the temperature. So reading it right now, I'm reading, around, let's get the magnifying glass out here. So we'll see the temperature drop to about 5 degrees almost. Okay? So this is an endothermic reaction. And to see that, we'll take the camera out real quick and put it against the thermometer here, and let's make sure we can see this. Okay, so you can clearly see we went from 20 degrees and dropped 5 degrees. So in this reaction, energy was basically taken away from the environment in the reaction. We got colder. Okay, so this is a cool experiment to show an endothermic reaction. Let me go ahead and put this guy back in its placeholder, its stand here. Okay, I'm still not done. What we want to do is, now that we've, so what we've done here basically is we've neutralized the citric acid with a base. So what we're going to do is, I'm going to get some, a nice clean rod, and we're going to stir this guy a little bit. And here's the key thing I'm going to do. We're going to do the litmus test paper test, okay? So let's go ahead and bring that up close to the camera. Here it is. And I'm going to put a drop onto this side of the test paper. Now notice that the color didn't change to red because we've neutralized the acid with the base, the sodium bicarbonate. Okay, so that's cool. All right, so this concludes our experiment illustrating a endothermic process with citric acid and sodium bicarbonate.